Alright, so today we're going to be talking about Lesson 4. This is Powers of Monomials. So if you recall from Lesson 3, I believe, if we have x to the 5th times x to the 5th, we keep the base, we add the exponents. So this is really x to the 5 plus 5, which happens to be x to the 10th. We can also rewrite this, though, as x to the 5th squared. Because now it's like this whole term is our new base. And when we have a power, which is this right here, remember x to the 5th, x is the base, 5 is the exponent, the whole term is a power. If we have a power raised to an exponent, we multiply the two exponents together. So we have 5 times 2, which happens to be 10. So now this whole part, this 6 to the 4th, this is our new base. This is our new exponent. And what this means is 6 to the 4th times 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 6 to the 4th. We have 5 4s. So if we were to do this with our power of a product rule, we'd add up all the exponents, we'd keep the base, and add all the exponents to be 20. In this case, we do 4 times 5, which still gets us 20. So in example 1, we have 5 squared raised to the 8th. This is going to be the same as 5. We multiply the two exponents, so 2 times 8. So this is really going to be 5 to the 16th. Example 2, we have a to the 3rd raised to the 7th. So this is going to be a 3 times 7, which happens to be 3 times 7 is 21. All right, let's make things just a little bit more difficult now, because now we have kind of a bigger base. This whole thing now, 6x to the 3rd, is a new base. But if we have this product inside the parentheses, and then that whole thing raised to an exponent, this exponent is kind of like the distributive property. So this exponent gets applied to the 6 and to the x to the 3rd. So it looks more like this now. 6 to the 2nd and x to the 3rd to the 2nd. 6 to the 2nd is 6 times 6. X to the 3rd raised to the 2nd power is x to the 3rd times x to the 3rd. We take this first part here, multiply them together to get 36. The second part here, we can either add the exponents, like we've done with product of a power, or we can use our power of a power rule from the back side of this paper. 3 times 2 will still get you 6. So example 3 here. 3c to the 4th, all raised to the 3rd power. This is going to be the same as the first part of our product, which is 3, raised to the 3rd power, times the second part of our product, which is c to the 4th, raised to the 3rd power. So 3 to the 3rd power is going to be the same as 3 times 3 times 3. And c to the 4th raised to the 3rd power is the same as c to the 4th times c to the 4th times c to the 4th. This part here, 3 times 3 times 3 is 27. This part here, if we use product of a power, 4 plus 4 plus 4 is 12. If we use our power of a power, 4 times 3 is still 12, so it would be c to the 12th. And then last example, example 4. Same thing. We now have 3 parts of our product in here. So each part, that's this negative 4, p to the 5th, and q, gets raised to the 2nd power. So this negative 4, remember, it has to be in parentheses. The next part is p to the 5th. And the next part is q. Now, in this case, q really has an exponent of 1 right here. So we can actually put that in there. Negative 4 squared is the same as negative 4 times negative 4, which happens to be 16. Make sure that it's positive. Negative 4 has to be in parentheses. P to the 5th raised to the 2nd power. If we use our power of a power rule from the previous page, 5 times 2 is 10. And same thing here, if we use our power of a power rule, 1 times 2 is 2. So the answer would be 16 p to the 10th q squared. All right, that is the end of this lesson. If you have any questions, please let me know.